Hey everybody, welcome to the video Unapply Apply, a custom aggregating function in pandas. This video targets experienced pandas users who want to optimize custom aggregating functions when grouping. So whenever you develop a custom aggregating function and use it within a group by, you have potential to be doing one of the absolute slowest operations in pandas. So this video is going to show you how to get a huge performance gain by using the built-in functions. So to do this, I'm going to use a simple and contrived example to show you how to efficiently rewrite a group by apply. So typically when you have a custom aggregating function, you will pass it to the apply method. And we're going to rewrite this so that it is done optimally. Okay, so let's get started. I'm going to create a very simple data frame with two columns. There's going to be 1,000,000 values, so it's a fairly large amount of data. There's going to be 1,000 different groups and 1,000,000 values between 0 and 1. So this DF is, has 1,000,000 rows, 2 columns. There's 1,000 different groups and a bunch of floating point numbers between 0 and 1 as values. So here's the problem statement. For each group, we're going to calculate the sum, mean, median, and difference between the mean and median of the value column, but only for values greater than 0.5. So this is a fairly simple problem until we get to this condition for only values greater than 0.5. Now, I realize you can solve this quite simply by essentially filtering out the data first by 0.5, but I'm just going to not show you that, and that is actually not the trick. But I do want to have a particular condition in here for a reason that's going to necessitate a custom grouping function. So just keep that in mind when doing this problem. It is contrived, like I said, but it's done in a manner so that I can show you some very clear and concrete steps on how to sort of unapply a custom grouping function, to rewrite a custom grouping function. All right. So before we actually solve the exact problem statement, let's find the sum, mean, and median for each group. So we're going to just simply disregard this condition for the moment and just do a simple group by that uses these, that's able to find these aggregations. So to do this, we use the group by method, and we're going to group by group, and we're going to take the value column and we're going to aggregate the value column, and we're going to aggregate this value column with the sum, the mean, and the median. And so we get this resulting data frame, so we should have 1,000 rows, 1 for each group, and then the aggregation for that group. Now, sum, mean, and median are all built-in aggregations. So I didn't calculate the difference between the mean and the mean, but just for simplicity, I just wanted to show the things that are built in here. So this is what I mean by built-in. Pandas has already built us a sum function to calculate the sum of a group. It's built a mean function to calculate the mean of a group. It's built a median function to calculate the median of a group. There's about 15 to 20 built-in aggregating functions that are available for you to use. You can look them up in the documentation. Now, our problem contains a little curveball in that we want to only sum up these, or only calculate these aggregations for values greater than 0.5. Now, there doesn't exist a specific function that does this in Pandas. So there's no built-in function that says, hey, if the value is greater than 0.5, then do sum, mean, or median. You are forced to write a custom aggregating function here. So because it is not built in. There's nothing that says, that is able to provide us a condition like this. So that's what I mean by writing a custom aggregating function. Okay, so let's go ahead and do this, and let's just show the first 3 rows here. So the way we're going to do this is, I'll just call it F, and I will define it like this. So what's passed to the custom aggregating function is actually the entire data frame. So you have to think of X as a data frame. So what we're going to do here is, first we want to build a filter such that the values are greater than 0.5. So I'm going to call this filt, and I'm going to say, so it's passing the data frame in for each group. So that's what is being passed into this custom function implicitly. So we'll see that in just a second. But we want only the values greater than 0.5. And so we can actually filter these values. We could say high values equals x.loc. So we're going to do use the loc indexer to filter out the values and only return the values. So what I've done here is for every group, we're just going to create a filter, a Boolean filter, and use this Boolean indexing, Boolean selection, in order to just select the values of that group that are greater than 0.5. So this guarantees us these high values are greater than 0.5. So what we can do here now is just simply calculate the sum, mean, and median. So I'm going to go ahead and do that. Since sum is a reserved word, we'll just do sum underscore and say high values. This is now a pandas series, and we can do dot sum, and we can say mean is high values dot mean, and median is high values dot median. And then we have this difference, so we can just call it diff is between the mean minus median. And we can return this. The way to create a new column for each aggregation is to return it as a series. And we can make a dictionary here mapping the new column name with the actual aggregation. So I'm going to create a dictionary here, and we'll say mean is going to be mapped to mean, and median is going to be mapped to median, and diff will be mapped to diff. Okay, so this custom aggregating function, and let's go ahead and call it. So we can do df.group by group, and we're going to use a ply here to pass it in. So we're going to send, we're going to say, hey, instead of doing any built-in aggregating functions that pandas already has, use this one. Use this f that I created. So you just have to know that x is past the entire data frame here. So for each group, so it's past each like sub data frame. All right, so if we run this, and it's called value, not values, we should get a data frame that has the sum, mean, and median, and the difference between the median and the median, just for the values greater than 0.5. So that looks correct. The mean and the median should be about 0.75. And the sum, I suppose, should be, looks about right, so it should be about 1,000. About half of those are greater than 0.5, so that's about 500, and an average of 0.75, so 500 times 0.75, 3/4, 15/4, so 375. So that looks like a correct, so it should be right around 375. So let's go ahead and just look at the top three, and you can tell it's actually taking some time. So whenever I run this, it's already taking some time here to calculate that. It looks like maybe about a second to calculate that. If I run this using the built-in, it happens immediately. So you can already see that there is a difference here. Okay, so this is a way to get a correct result, but it does it quite slowly. So we can massively improve this by doing a little trick. So yes, here's the reason why it's slow. So the custom function is run for each group. So every time, every group, for every 1,000 groups, so each one of our 1,000 groups, it's going to pass this data frame in there. It's got to do all these custom, all these calculations, and finally return, and then I even create a little series here, and finally just return that to get our desired result. So it's doing all this work for every single group. Now, if you go back up here, these are done also for each group. So the sum is being done 1,000 times, but it's not all these lines of code. And plus, Pandas has already sort of optimized. It's already written the code for us to do the sum. So these are going to be more optimal than our custom function, which we are doing right here. So that's the reason for the massive slow up. These are not optimized, and there's more steps. Okay, so here are some steps to unapply this, this apply function. So what we're going to do is not rely on the apply function. We're not going to rely on a custom function itself. We're only going to rely on these built-in functions. But to do this, we have to sort of prepare our data beforehand. And so here are the rules. Here are the sort of steps to unapply and apply. So number one is compute group independent operations before the group by. These calculations are applied to the entire data frame as a whole. So I'm going to start there. So group independent operations. So these are operations that happen in our custom function that are not dependent on the particular group. So for instance, our filter right here is not dependent on the group. So it doesn't matter if you're in group 500 or group 300 or group 99 or 999 or whatever. This filter will work the exact same way. So if you did have something in here that depended on the group that said like, hey, if the group was odd or something, then do greater than 0.7. If it's even, do less than 0.3 or something. That would be different. But there's nothing that is dependent on the group. There's nothing that has the word group in here. So we can do this before the group by. So that is one of the bigger tricks. So what we're going to do here is we'll create the filter again, but we're going to do this on the entire data frame. So df value is greater than 0.5. Okay. Now, what we want to do is basically filter out these values for each group. So one of the ways to do this, is to create a new column that only has these values. So what we can do here is we can multiply the value times the filter, and this will sort of zero it out, and we can see that only the values that are greater than 0.5 are left. So while this is good to zero them out, the zeros are meaningful with the mean and the median. So this will get us incorrect results. So what we need to do is use a method called where, and where will make them missing. So now we've created a new column. It's the same length. It has 1,000,000 values. And what where does is for the true values, it keeps them what they originally were. So this is the original value. For the false values, it just makes them null, makes them missing. So this just sort of removes all that data, but keeps the same dimensions of the column. So what this allows us to do, we can just create this as a new column called value large. And now we have a brand new column over here called value large. Now, this column is set up so that we can do, we can call these custom aggregating functions. Okay, so we don't have to do the filter in here. We don't have to do any of this stuff anymore. We can directly call our custom aggregating functions. So let's go ahead and do that. So now df, we can do df.groupBy again, group, and we can group and then aggregate the value, and we can do the same thing. We can do sum, mean, and median, and let's call this df2. So we can see here, let me just call the head of this. All right, and I didn't do the right one, so value large, not the old one. Okay. So yes, this should get us the same answers as we did up here. So 393, 397, 0.76, 0.763. So it looks like it's the same. Now, notice that there is no custom function for mean minus, or there's no built-in function for mean minus median. But this can be calculated afterwards, not during the group by. And the reason you want to calculate it afterwards is that it only happens one time. You don't have to do it for every single group. So it is also not dependent on the group, and we can calculate this afterwards. So let's add one more column. and we'll just call it diff, like we did above, and we'll just say df2 mean minus median, and now we will have completely replicated df2. Okay. Now we'll have completely replicated the custom function from above. So we can put all these steps together in one, just so that we have them all together. So let's go ahead and put them in one single cell. So we create our filter, we create a new column, and then we do our grouping. And then if there are any extra columns that need to be added after that depend on the group, the aggregation, then you add them at the end. So this will, do the same thing again, all together in just one step. And you can see this is happening quite fast. So if we time this, we can see that, and I'll just run this. So that took 126 milliseconds. And the custom aggregating function is going to take quite a bit longer here. But the time it is usually good at figuring out how many runs it needs to do. So it said it did 1.74 seconds. So this is about, right now it's 15 times slower. You might, I'm recording a video, so the times could be quite different. But you should get at least an order of magnitude, improvement, if not more. And so there is a substantial difference in doing this pre-calculating of things that are independent of the group, and then aggregating with just the built-in functions. So that is the trick. So try to do your calculations outside of the group by, and then rely only on the built-in aggregating functions that Pandas already has built for you. Do not try to avoid using a custom aggregating function if you can. And then, if you do have columns that require calculations that depend on the aggregations, do them after the group by, as we did with the diff column, and that should be the last step. Okay, so I hope you guys enjoyed that video. I have a lot of comprehensive material that you can learn from. In particular, one of my books is called Master Data Analysis with Python. You can get this at dunderdata.com. It comes with 300 exercises and solutions. I'm in the process of making videos for it. I've made 12 hours of videos for it so far. Also, if you want to attend a live class with me, I'm having live classes in Houston, Texas, coming up at October 7th through 11th, and later in the year, December 9th through 20th. And then again, I'm doing classes in New York City from November 4th through 10th. This book is extremely good. I think it is the most comprehensive text available that covers, how to do data analysis with Python. And then the live classes are very interactive, very hands-on, lots of exercises, and lots of personal help. So if you can, check these out. I don't think you'll be disappointed. All right, so that again is how to apply a custom aggregating function in Pandas.